to help create new connectivity options for vehicles. And before that, he was Vice President of Business Development at GM's OnStar subsidiary. Nick will start us off with a look at where the connected vehicle came from and where it's going. So, ladies and gentlemen, Nick Pudar.
Thanks, Bill. Well, good morning. Thank you. It's a pleasure to be here. And I was asked to answer this question of what is the connected vehicle and how is it going to change everything for us. And I know that in this kind of a setting, there are folks here who want to know what is a connected vehicle, and there's folks here who have actually pioneered the technology and what's made it possible. And what I want to focus on is this journey that the industry's been on. And GM's been part of this journey for quite some time. And our current strategy is really at an interesting pivot point in what is possible and what can be enabled. Now, it's always important to take a look back, sort of what that journey's been about and sort of how we got here. And if I was to ask you to, when do you think the connected vehicle really began to be seriously explored, when would you think it was? I'm not going to solicit answers, but just in your own mind, think about when that might have been. I'll give you a hint. OnStar's been around for 18 years now, and I've been part of that journey right from the early conception stages, but it started even before that. Actually, back in 1966, there were folks inside GM that were working on this question of how do I connect the vehicle to its environment so that it can actually provide important information to the driver to keep them safe. And there was this solution that was called the Driver Aid Information and Routing System. And the way this worked was that we would embed triplets of magnets in the roadway. And either the north or the south pole was pointing up. Therefore, you had 2 to the third 8 possible pieces of information. That's 1 byte of data. And depending upon what information you encoded in subsequent sequential bytes, you could actually store some information in that road about the road, such as what is the speed limit, what road am I on, and using the embedded data in the network of the roads, the vehicle, which had a magnetic pickup on the bumper, it could receive that information and interpret and provide you navigation services based on the actual road data. One of the things we learned was that it is interesting, but it's hard because of the significant infrastructure of embedding magnets in roadways. And so that was a consideration, and I'm sure that somebody someplace said, hey, we got potholes to worry about as well. So, that was a learning, and we said, okay, interesting, but not going to be able to be scaled. But one thing that I want to point out is on the center console of this vehicle, there was a rotary phone that we used to dial because we also incorporated some radio walkie-talkie technology to allow people to make phone calls from their vehicle. And then that other little device in the upper left-hand corner sat on the dashboard and provided real-time speed limit information and some other navigational directional icons to help you get to where you're supposed to go. I also find it amusing that we still call it dial today, but I don't know why we do, but we do. But that was sort of one part of the journey. Then in 1987, again, with the desire to bring connectedness to the driver to provide better passenger communication outside the vehicle when they're in the vehicle, there was an exploration of using microwave towers to across the country, and we would build our own communication network with microwave towers. And the cost was pretty exorbitant, and so we didn't do that because we could not justify building out a communication network because we're a car company. And so that was shelved. And then, again, the strong desire to figure this out continued. And then in 1994, there was an internal project at GM called Project Beacon. And at the time, we had Hughes Electronics as part of the corporation, EDS, the automotive business. And we leveraged these assets, these unique strengths that the corporation had, to prove out quite successfully that there was a viable business model here. And we were going to leverage the cellular infrastructure that was emerging and becoming quite dominant in our environment to build this out. But we also discovered something else, that this kind of a heavy corporate governance structure was really hard, and that we needed to run it as a startup inside a big company, not 3 different companies trying to negotiate with each other. And from that, very quickly, we created the OnStar business. And so it launched in '96. And as you know, it's a service that uses cellular technology, GPS for location, data centers, call centers, some vehicle electronics, make it all stitched together and quite easily create this, this service that we provided for now 18 years. Safety, security, navigation support, diagnostic information from the vehicle. And we've enhanced this, this service over the years. But one interesting thing to point out is at the beginning, when we were told, hey, this is all well-known technology and it's going to be no big deal to put it all together. Well, either we were being lied to or people just didn't know how hard it was going to be, because it was hard. It was hard to build it robustly, to make it work, and you know, several 1,000 patent filings later and many that have been granted, we continue to file patents once every 5 days. There's still so much room to build this connectivity in a much more robust way. But the question is sort of, what is the connectivity? It allows the occupant of the vehicle to have connection to the outside world when they're in the vehicle. It also allows people outside the vehicle to have connection to their vehicle if they need it for certain information. And we'll get into some examples of that in a second. But then in 2010, there was an interesting change. We started to leverage APIs. Now, who knows what an API is? API is a little bit of geeky speak, and I'll tell you what it is. It's an application programming interface. And to boil it down to its very simplest element, it's how one computer asks another computer for information. It's a standard way. Hey, I need this information. And this system says, are you authorized? Yes, I am. Here it is. That's all it is. And so if certain information, certain data can be exchanged between different computing environments, you can now begin to program very unique services and systems and solutions that benefit the vehicle owner, the vehicle occupants, society. And so there's this question of how does the connected nature of the vehicle with respect to other things in the world, how does that create value? This is going to be the last sort of geeky part of the talk. You know, in the early days, there was the Sarnoff model of the value of a network, and it was the NBC model of broadcast. So the number of people that are receiving the signal, the value of the network, is directly proportional to the number of people receiving the signal. That was the value of that network. Then who's heard of Metcalfe's law? Metcalfe's law is that the value of a network is proportional to the square of the number of nodes in the network. So it starts to value the number of connectivities, the connections. But what's really been unleashed here recently with sort of the Web 2.0 world is Reed's law. David Reed, MIT professor, entrepreneur, innovator. He states that the value of a network is proportional to 2 to the n. In other words, it's a significantly higher exponentiation of the value. And that is, the more people there are that are part of the network, the more valuable it is to me uniquely. So, you know, the person who bought the very first fax machine was a trusting soul, okay? And so the more people that participate in a particular network, the more value it brings me. That is what the connected vehicle is going to unleash for us today. But I'll bring it back to this notion of APIs. APIs, how does a computer talk to another computer? We started to transform our infrastructure in our back office to this API structure, this service-oriented architecture approach. And we began to use it for our own applications. And so in 2010, we built several applications. We created a remote link application for the Chevy Volt that allowed the app to communicate with the Volt. What's the state of charge? Is it still charging? We put nice little human touches in there so that if the vehicle was not plugged in, and when I had mine, I had it set for 10 p.m. If the vehicle's not plugged in at 10 p.m., send me a text message to remind me. And on a few occasions, I had forgotten. I'd run out to do an errand, and I'd forgot to plug it in. And the next morning, I would have not had a charge, but that didn't matter because the Volt can run on gasoline, but I didn't like that. So that was a way in which we began to leverage this capability of very rapidly developing applications in websites, in emails where the vehicle can send unique emails directly from itself. This API structure was what really began this very fast-paced capability. But today's reality is that we're opening up our APIs for third-party developers to be able to innovate and create new solutions in a wide variety of domains, including the urban mobility arena. And so there's really 2 kinds of these APIs. There's APIs that can run on apps that are in the vehicle, and so you're going to see a lot more vehicles in our portfolio where there's going to be a touch screen where you can download apps that are dedicated to the vehicle that run specifically in a very safe environment, in a very safe structure that give you the kind of tools and capabilities that you need while you're in the vehicle. There's also remote APIs that allow apps on smartphones, on websites, on other corporate servers to interact with the vehicle directly, of course with customer consent and opt-in. And so this ability to create a programmable vehicle that allows third-party developers to build new innovative solutions to solve real human problems, that's the exciting part of what the connected vehicle is doing for us. In order to help make this happen, GM also last year opened up a web portal. And so for developers, it's developer.gm.com where you can check it out. And it has the SDK and the emulators and all the full documentation for the developer community to know how to develop apps. It goes through a rigorous validation process and certification process at GM. And you're going to start to see a growing array of connected solutions that, quite frankly, didn't come from us. But the vehicle in its connected state allows this new capability. Now, over the years, I've seen many presentations on connectivity. And you go back, however long you want to go back, there's always this sort of archetypical slide. It was a picture of a car, and then all around it were other things that it connected to. And that was completely the wrong frame. The right frame was to have the person, the customer, or community in the center of that picture with a whole bunch of stuff around that person. And the car happens to be one of them. And so the way we're architecting our business and thinking about how to bring this connectivity to life is that we know that customers would like their vehicles in the right situations to be part of their digital lifestyle. But they also want their digital lifestyle to be part of the vehicle. And so I'll talk more about sort of how that becomes enabled with some examples. But here's one example of a smart grid. So we've done a lot of work with smart grid where the vehicle, because it can communicate with our back office servers, you can find out whether it's charging or not. You can do some great demand response solutions. So if I plug my vehicle in and I'm part of a demand response program, I will allow the utility to interrupt my charge if the system needs that capacity. And so simple things like that. I can also do off-peak charging schedules. I can also do dynamic pricing tables where we actually have it set up so that a utility can download to the vehicle the pricing structure and the pricing schedule and time so that the vehicle can optimize its charging regimen based upon lowest cost. But there's an interesting thing that becomes enabled as well. Let's suppose there's renewable energy in the network. And so now the network, the grid, knows there's renewable energy. And I've heard situations where sometimes the utilities don't know what to do with it because there isn't demand for it. And so the pricing gets a little crazy, and sometimes they pay people to use electricity. But in this situation, let's suppose that you have a Volt or a Cadillac ELR, and it's plugged in, but you're waiting for the off-peak rates to charge, so it's not charging. But the system knows there's renewable energy in the network. Well, we have it set up with a working, fully functional pilot program where the grid sends us, OnStar, a signal that says, through APIs of course, sends us a signal that says, hey, we've got renewable energy in this particular part of the grid. We then send a message to all the participating vehicles, and they say, oh, okay, I'll charge now. And so this is the first time that I'm aware where customers can have a real demand signal for renewable energy. So this is just a simple example, but we're going to see a lot more of this kind of creative approaches in various ranges of our space. How about urban mobility? There's lots of companies out there in the car sharing space, in the carpooling space. And if the vehicle, right from get-go, has the ability to provide information about its location, about its occupancy, about whatever the developers can conceive of, it begins to enable new services at lower cost for these innovative car share services that are out there. And so instead of having to retrofit a fleet of vehicles with expensive hardware, the vehicle can do this now. It's just a matter of providing the right handshakes through these APIs. Who has heard of IFTTT, IFT? One? Okay, that's typically how many hands go up. IFT is an acronym for if this, then that. And it's actually a website. You can go there. It's www.ifttt.com. And I'll give you a couple of examples of things that it can do. It has channels and events, and what do we want to do? So here, if I take a picture with my Instagram account, then send it to my son's Dropbox. That's just, you can set up channel to events, and they call this little if this then that structure a recipe. And there are literally tens of thousands of recipes of things that people have concocted based upon the APIs that different services have allowed participation in. Another example is if in Facebook my picture is tagged, then copy that image to my Google Drive account. It just happens in the background. There's other examples. If a certain stock price gets to a point, send me a text message. If it's raining outside in the morning, send me a text message to remind me to take an umbrella. So there's all kinds of things that people have programmed. Another example is if I am near my health club, give me an attaboy. So there's lots of things that people have developed in a programmatic way to connect their life in a meaningful way. But what if this kind of capability was applied to vehicles? And in fact, that's what we're doing with this API approach, with the developer approach. So here's an example, and we've kind of been doing this at OnStar. If an airbag is deployed, then send the location information to an advisor to provide the appropriate dispatch. Now, we've kept this aspect of our vehicle capability to ourselves because we want to make sure that's a very robust service. But what about something like this? If the rain sensor in my vehicle is triggered, then send that GPS information and maybe even the speed of the wiper blades to the Weather Channel, so that we can now begin to create micro-weather forecasting capabilities and become a very significant piece of data collection for the weather system. And people have talked about this, but it's very real and very practical to do now. It's very simple for the customer to opt in, and they become part of a solution. More is possible here in this context of this thing called an intent engine. With all of this connectivity, if you're sensing that now you've got to go into a website and program everything on your, to work for you, it can get pretty daunting. But there are going to be solutions that begin to, with your permission, of course, and with your configuration, can begin to infer your intentions and begin to take actions. And this connection now can reach out into a whole broader range of devices and applications and calendaring systems and medical devices. And again, the possibilities are endless. The creativity is out there. Developers are going to be focused on this. Startups are going to emerge around this ability to connect things. And I've talked to lots of developers over the last couple of years, and they just view the vehicle, oh, it's connected? Does it have APIs? Great, I'm going to include it in my solutions. And their solutions may not be about mobility. They may not be about the vehicle, but all of a sudden it makes the vehicle a relevant part of the solution that is important to a customer. The one thing I mentioned, we've opened up this developer portal, and we've been dealing with a lot of developers. We've also participated in something called hackathons. Hackathons are these sponsored contests that happen all over the place. As a matter of fact, there's probably one going on right now someplace in the country. And it's developers get together. There's some companies sponsor it with cash prizes, some giveaways. They present a challenge to the developers, and the developers work for 28, 36, 48 hours, whatever it is, the duration, nonstop, fueled by energy drinks and pizza. And at the end of it, they present for 1 minute only their solution, the demonstration, and the best ideas, win the prizes. And we've participated in probably a dozen of these over the last year. And I'll just give you two examples of a couple of the winners. So in one example, it was at the TechCrunch Disrupt New York conference earlier last year. And there were about 860 developers that showed up to this event. It was in a great big auditorium. And there were 15 companies. GM was one of them. We had given the challenge, we would like you to develop an app for our in-vehicle system. Here's all the information that you can pull off the vehicle, have at it. And the prize was, I think it was $4,000 in cash. So there was actually $4,001 bills sitting on the table, and everybody would come touch it, take pictures with it, smell it, and stuff like that. And there was these four very young people, aged 15, 16, and 17, that were mesmerized by the cash and said, what do we have to do to win that? And we said, well, write an app for a car. And they said, well, what should we write? And we said, well, that's up to you. You guys, what should a car have? And they said, well, we don't know. We don't drive yet. And we said, the answer, well, it's perfect, because you should tell us what you think a car should have and go build it. So off they went, and through the next 30-some hours, they were working. And we never really saw what they were working on until the very end when they stood up to present. And they got up and said, well, we don't drive, but we wish a car had this. It's the Learn to Drive app. And the app would provide you with both auditory and visual instructions on how to do 15 key maneuvers that are part of driver instruction school. It also would tell you, based upon where the car is, it would do a search of the DOT system to see what the actual speed limit is on that road segment, because it may not be what's posted. It may be a construction lower speed limit. And they would tell the driver, the student driver, if they were going too fast. And they said, and in many states, our parents are supposed to keep logs of our driving as part of the graduated driving instructor program. They're supposed to keep track of daytime and nighttime hours, but they're not very good at that. And so the car looks up to see when was sunrise, when was sunset. It knows if I'm driving, it logs the hours and gives me a weekly summary of my progress. That was a great idea. And they won our first place, and they came in second place overall. So that's one example of the kind of innovation that can occur in this space. Another example was a group of developers pulled all the telemetry data out of the vehicle and configured it into a very dynamic graphical interface that gave you real-time feedback about the fuel-efficient driving behaviors that you had. And you can literally, viscerally figure out how certain behaviors, without it telling you what you're supposed to be doing, you'd figure out how to drive to save fuel. They then projected that data to an iPad, did a mirror image on the iPad, put the iPad on the dashboard and created their own makeshift head-up display to give the driver this information. Very clever stuff. So we're going to see a significant amount of innovation that comes from this stuff. But the ability to connect the vehicle to a wide variety of devices and services is what creates this, this range of possibilities. So let's talk about a carpool example. So let's say there's a carpool, and one thing that you would like to be is punctual. And so in this example, the car's proximity to the rider's home, it will actually give them a text message. Let's say in 5 minutes it's time to go. And so that way, the punctuality and reducing the uncertainty of the carpool activity and helping optimize the time, makes it a more pleasant experience for all people concerned. So little things like that become very possible. How about the proximity to home establishes the Nest thermometer to set the temperature more comfortably. So instead of figuring out what my normal schedule is, I want the thermometer to react to my actual activities. And of course, that would imply that it needs to know whether my wife or kids are at home as well, use their smartphones as that proxy for where, what's going on. In the experimentation phase, I'll tell you a funny story. In the experimentation phase, we had rigged my car to do this proximity stuff, and so I had set it up so that when I was 10 minutes from home, it would send my wife a text message. And that was cute for a while. And one time I was traveling in West Coast, and she called me. She says, "Where are you?" I said, "I'm on the West Coast." "Why?" She said, "Because your car just texted me, and it said it's coming home." Well, I had forgotten that I had traded cars, company cars, with another employee. And he happened to just be crossing through that radius at the time, and it caused a little commotion. So lots of things to think about when we're designing and leveraging the connectivity. Here's my favorite example. This is the one that says, when my wife's car gets to less than quarter tank, it sends my phone a text message so that I can fix that problem for her. So again, this notion of programmable personalization is a very big deal, and I think it becomes very exciting to see. My son has offered to code this, by the way. So now, the question is, we need to understand all stakeholders, all right? And so all the capabilities and all the possibilities are fun, and there's a lot of creative, innovative stuff that's out there. But each one of us, at every moment in time, are part of three different stakeholder groups. We are individuals, we are citizens, we are also part of an enterprise, and we are also part of a community. And every one of these constituencies have a set of desires and a set of concerns. So you will have the exact same set of desires and concerns that are at conflict with each other. And so solving, the intersection of any two of these stakeholders is, hard work, but it's doable. Solving the intersection of all three is really difficult. That's what we call a systemic solution. So when we think about, the individual, what do they want? They want privacy. They want confident access to what they're supposed to have. And especially in the space of mobility, there's this theme of confident access. Take the uncertainties away is a very important piece. And then also very transparent control. These are the things that matter to the individual. For an enterprise who's going to be providing solutions in this space, they really want to make sure that they've managed their risk. And this is a big deal. make sure that they are able to compete in an effective way, provide efficient operations, and really important is security to make sure that we address those issues. So that's what an enterprise has got their mind focused on. Communities want unconstrained access for the citizens. So if it's about congestion, if it's about access to commerce, if it's about fairness, there's a whole variety of things. This equity of access is important, but also want to handle these externalities. We want to minimize the unintended consequences. And so to address all these things takes hard work. It takes participation from everybody in this room in whatever constituency, whatever organization you're part of, to find the right solution. Because there are some great things that are possible, and I think we can work our way through addressing the concerns and needs of all the people. Bringing it back, we recognize that the car is going to become part of people's digital lifestyle, and their digital lifestyle will become relevant in the car. Whether it's for personal use, whether it's part of urban mobility solutions, car sharing, whatever it is, the way in which the car connects will enable a lot of things in the future. With that, I thank you very much.
Nick, before you go, I have a question for you.
All right.
One of the things that, the connectivity is certainly offering up a ton of options and possible services, but all that connecting is creating a lot of bandwidth demand. There's a lot of information flowing back and forth, particularly if every car on the road is talking to each other. Is there enough bandwidth out there to make this happen?
The wonderful thing about demand is supply finds its way. And so people today, when they're driving, are using their cell phones. And so there's the peak consumption of bandwidth is happening when people are, in the regular drive times. And so, we've introduced for this next year 4G LTE connectivity into our vehicles, and it's going to provide opportunities for when there are passengers in vehicles to have access to Wi-Fi. And so the answer is that the industry is always working very diligently to create more bandwidth, and we're also working to be very effective and efficient in the use of that bandwidth. And some of the examples that I shared don't require a lot of bandwidth. These APIs don't use much bandwidth at all. And so if you can be very, in a very pinpointed way, identify what it is that you need to unleash a service, then we'll be fine.
Thanks so much for joining us.
Thank you.
Thank you. We'll be back in just a second. We're going to bring our next panel out now, so stand by and we'll be right back. Thank you.